This is Lesson 6, Seeing Sounds. So although we can't see sound, what we can do is create sounds and put them into an electrical oscilloscope, convert them into electrical waves, in other words, and you can see them on the oscilloscope. So it says, which piece of equipment produces signals over a range of frequencies and of varying amplitudes? And that's our signal generator. Convert signals into sound waves, and that's our cathode ray. Sorry, it's not our cathode ray oscilloscope, it's our loudspeaker, so we can hear them. And then it's used to study the frequency and loudness of sound, and that's our cathode ray oscilloscope. It's often shortened, COPE, often shortened to CRO, or in this case they've just called it an oscilloscope. Now, we use this to look at the difference between loud and quiet sounds, or high-pitched and low-pitched sounds. So loud and quiet sounds, what is the difference between a sound of a quiet, the sound wave of a quiet sound and a loud sound? And you can see a quiet sound, a loud sound. The only difference between them there is that they have got a higher amplitude. Now, the wavelength here is slightly different as well, unfortunately, but what we're looking at here is the amplitude. So the louder the sound, the greater the height of the wave. And so that sound there is louder, the amplitude is greater. What is the difference between a low-pitched sound and a high-pitched sound? There's a low-pitched sound and there's a high-pitched sound. And you can see there, they're the same height this time, but there's more waves shown on the screen here than there is here. So a high-pitched sound has got a higher, I'll just scan in a wee bit, frequency. But it has a shorter wavelength, so you can see from there to there is a wavelength compared to there to there. So it has a shorter wavelength. And if it is shorter wavelength, then you can see more waves on the screen. So we then did an experiment to look at the human hearing range, and we set the volume and kept it at a constant value on our signal generator, and we started to increase the frequency of the signal generator. So you were able to detect when you first heard a sound, and then you heard the sounds for a long time, and then eventually you couldn't hear the sound anymore, even though we kept turning up the frequency on the signal generator. So the range of frequencies you can hear is called your normal hearing range. And the normal hearing range of a person whose hearing hasn't got defective hearing is from 20 hertz up to 20,000. And sometimes we write 20 kilohertz. Now, some of you were able to hear a frequency lower than 20. You'll not be able to hear a frequency higher than 20 kilohertz. That's called ultrasound, and it's only heard by certain mammals like mice and so on. Do we all have the same hearing? The answer is no. We all have a slightly different hearing range, but almost 1 in 5 people suffer some sort of hearing loss. So you may suffer a hearing loss temporarily if you have an ear infection, or you have a cold, or possibly you've been out for a night at somewhere where there was a loud noise and you hear ringing in your ears when you come in, but that eventually goes. That's a temporary hearing loss. Permanent hearing loss and deafness can be present at birth or occur if the ear is diseased or it becomes damaged. Now, sometimes people would suffer permanent hearing loss after having meningitis. Sometimes they might suffer permanent hearing loss after being very close to a very loud explosion or a very loud noise. All people lose the ability to hear sounds of high frequency as they get older. So I wouldn't be able to hear sounds of high frequency as you are. And so it's a high frequency end, the 20 kilohertz end, that would be affected. So I would be able to hear up to a lower frequency than that. You should probably be able to hear up to about 20 kilohertz. And the last slide, do all animals have the same hearing range? And the answer is no. You can see the human range there. It's just slightly above 10, which is about 20, up to 20,000. Dog, a bit more than that, can't hear just as low frequencies as us, but can definitely hear higher than 20,000. A bat is only able to hear very high frequency noises from maybe 500 hertz up to 100,000. An elephant has a very wide range of hearing. Apparently when the tsunami happened in Asia in 2002, wasn't it? Some of the elephants retreated inland because they heard the vibration of the wave coming. Mice are again very much more sensitive to high frequency sounds, and dolphins the same. They have just a far wider range. It's not that different to our own, but it's definitely up to the higher frequencies. They can hear better.